Now in 4.3, we're going to investigate transformations of quadratics. What transformations are taking values and then you're adding it to your base graph. So your base graph or your parent graph is just regular y equals x squared. No values on the end, just y equals x squared. And we're going to add values to this to see what happens to the transformations. In order to do that, though, you're going to investigate, and you need some sort of technology. So whether you're using a graphing calculator, or I can show you here, there's this awesome website called Desmos. And here it has all the tools. You just type your equation, and you can add as many equations as you'd like to your graph, and it gives you the color, and then it pops up just as you do it. So here's the table that we're going to graph, and I've already filled in this graph. And so we're going to graph x squared plus 2, x squared minus 3. And we're going to see what happens when we add a value onto the end of x squared or subtract a value onto the end of x squared, what happens. So the reddy colored graph is just your x squared. Your blue is your x squared plus 2. And your green is your x squared minus 3. And so if you've noticed, the plus 2 on the end moved our parent graph or our base graph up to 2. And the minus 3 brought it down to 3. So our vertex changed in each case. So let's fill out the chart now. So all three parabolas still open up. The value we added here, and if we write it here as k, doing plus k to the end, it was 2. And in the third one, it was negative 3 that we put on the end as the k value. Our vertex changed. It went to 0, 2. And in this case, it went to 0, negative 3. Our axis of symmetry, again, is the x part of our vertex. It remained the same. And is it congruent to this shape? That means it's the same shape, meaning it was this no matter what. It did not get wider or skinnier, so that will be yes to all of them. And so what did you notice this value did? This value added onto the end moves it up or down. So that's the transformation of the k value. The next form is that we're going to affect the x value inside the squared. So we're going to put in this minus h. And so here we have minus 2. So our h value, now I want you to notice that we have minus 2 in here. Our h value is actually the opposite. So if we have positive 4 in here, our h value is actually negative 4. And so this is affecting inside the squared with the x. And so again, you go to your Desmos and graph these three equations. And so here I've done that. We have our x minus 2. Now I want you to notice on the graph here, this is our blue graph. We've gone over to positive 2. Even though it was minus 2, we went to positive 2. And we had plus 4 here as our h value, and this moved to negative 4. So it went in the opposite direction to what it said. And I'm also going to put in here, let's say if we did plus 2. And you'll see here, like from the last graph, that plus 2 simply just moved it up 2. Okay, so that changed our vertex over to 2 on the right and up to 2. And so let's record that into our table here. All of them still stayed up. Our vertex changed to the 2, 0 and negative 4, 0. So our axis of symmetry then also changed to the x value of our vertex, and the shape, it still remained the same. So I'm going to show you the next table, and I'd like you to graph these. Oh, and if we go back, so if we notice what happened here, what did this value do? This value shifted our graph left or right. And so the h value is the transformation of translating left or right. So here's the next table. Now just note that it's not negative 2 squared. It should be negative 2x squared and negative 0.5x squared. You're going to put these on Desmos or whichever technology you're using and fill in the chart. See what happens. And then push pause and then check back. So hopefully you got this filled in once you graphed it. And here are your a values. So this is in the form ax squared. So we just stated the a value. The previous one was h. The one before that was our k value. And so the only difference in this section here, if you notice, is that these parabolas were facing down. And so how we can tell that is any negative a always means that it opens down, which will mean a maximum. Our vertex remained the same, and our axis of symmetry also stayed the same. Now the part that was different is this part. It is not the congruent shape. So when we had 2, if you noticed, it got narrower. Or you could say it was stretched. When we had 0.5, it got wider than our original x squared, or compressed. And it's the same thing down here, except it was flipped upside down. So it was stretched, but it was just opening down. And here it was compressed, but it was just opening down. So the negative just affected. And so you can see the graphs here, and you can match the colors on the side with the stretching and compressing. The original one is the red one here of x squared. So there's a handout posted on the class site, which just gives a list of the transformations. So just to recap, when the a value is less than 0, it is a reflection. That's called a reflection in the x-axis that opens up or down. So if it's negative, it opens down. If it's positive, it opens up. When the a value was greater than 1 or less than -1, this is a vertical stretch. When the a value is between -1 and 1, it is a vertical compression. When we have this h value, when h is greater than 0, it is a translation to the right, and less than 0, it's a translation to the left. Just remember that for x minus h, it's the opposite here. So if it was -4, you're actually going to the right 4, where the minus might make you think that you're going to the left. You're actually going to the right, so it's the opposite. The k value, it's a vertical. If it's greater than 0, is a shift vertical translation upwards, and less than 0, it's downwards. So this is posted if you'd like to print that. So you also need to be able to sketch a transformed graph, and instead of using technology, but that is one of the ways, is to use technology. The other way is right now is we're going to use a table of values. Later on in the chapter, we're going to explore different ways that you can sketch, but for right now, it's going to be with a table of values. So you're first going to have to sketch this graph for this equation right here using a table of values. So generally, I've created this table of values. You pick the x values. Generally, these are the x values that we would pick, and we would have to determine the y values. So the first spot here, we have our equation y equals 3x squared plus 5. Now, if you look across from our y, though, we know what x is. X is -2. So we have to do -2 squared to solve for what our y value is. So we would have 3 times 4 plus 5, and then 12 plus 5, 17. So you're going to fill this table in all the way down by replacing this, so it's not -2 for the next one, it will be -1, and then solving for the value. So hopefully you got that filled in. You got, sorry, this should be 8, 17, 8, 5, 8, and 17. And notice that there's a pattern here with symmetry. So if you plot these points, 0, 5, 1, 8, -1, 8, 2, 17, -2, 17, and then you can graph your parabola. And so that's the first part, using the table of values. Then you have to describe the transformations. Transformations applied for this one are 3 and plus 5. So what does that 3 mean? The 3 means a vertical stretch by a factor of 3. And the plus 5 is a vertical shift or a vertical translation upwards of 5. And so you just have to state each transformation depending on what the equation was that's given. Part C, we're going to determine an equation for a parabola that is a vertical compression by a factor of 2/3 and a horizontal shift left 4 units. So we have y equals, if it's a vertical compression, that's our a value by a factor of 2/3. That's the part that goes in front. Then we have our x squared. We have a horizontal shift 4 units left. So if we went to the left, that would actually mean we need to put plus 4 because it comes out as the opposite and moves to the left. And those are the only factors. There's no k, so then that would be the equation there for part C. If you have any questions, please make sure you write them down and bring them to class.